Okay, last example from this homework. It's going to ask me to combine a lot of what I've learned about probability. Okay, so it's setting up a story problem, and I'm just going to start by keeping track of the information that it's giving me. Okay, so it says that the American Diabetes Association estimates that 8.3% of people in the United States have diabetes. Okay, so I'm going to start right there. 8.3% have diabetes in the country. Well, that means that 91.7% don't have diabetes, right? Suppose that a medical lab has developed a simple diagnostic test for diabetes that is 98% accurate for people who have the disease. So it's 98% accurate, but only 98% accurate for this group. It's not 98% accurate for this group. So this group, it's 98% accurate, which means it's 2% inaccurate. If I go back to reading, it's 95% accurate for people who do not have diabetes. Okay, so this group, it's 95% accurate, and it's 5% inaccurate. So the medical lab gives the test to a random person. What is the probability that the diagnosis is correct or that the diagnosis is accurate? Okay, so it has split up people into two different groups, right? I've got the people who have diabetes and the people who don't have diabetes. So I'm going to have to find two different probabilities and add them together because I want to take these accurate people and add them to these accurate people. But I can't just combine these percentages because this is saying that 98% of the people in this group, not out of everybody, but 98% of the people in this group, it's accurate. And 95% of the people in this group, it's accurate. Not everybody, just the people in that group. So the way I'm going to do this is I'm going to take 8.3% and I'm going to times that by 98%. But when I write that, I don't want to do 8.3%. I need to write it as a decimal. So 0.083 multiplied by 0.98. So 0.083, that group, that chunk of the population, it's 98% accurate. On this other side, 91.7% of the population, it's 95% accurate. So this one, I'm going to write 0.917, and I'm going to multiply that by, what do I want to multiply that by? 0.95. So I've got two different groups here of probabilities that I need to add together. So let's do that on the calculator. 0.083 times 0.98. Nope, that's not the calculator. 0.083 times 0.98. Then I'm going to add 0.917 times 0.95, right? Because, yep, I think those are the right numbers that I wrote down. When I hit enter, I get 0.95249, which represents a percentage, 95.249%, right? So 95.249% or 0.95249 is correct. That's the percentage of tests that are correct, depending on if you have the disease or not. But out of everybody, 95% of the time, a little bit more than 95% of the time, it's correct. Okay, let's look at the next two. An example 4, what's the probability that the diagnosis is not correct? Okay, well, it's incorrect for 8.3% of the population. It's 2% incorrect for 8.3%. So for 0.083, it's 2% incorrect. And then for the other part of the population, for 91.7% of people, it's 5% inaccurate. So plus 0.917 times 0.05. So let's put those in. 0.083, nope, not that calculator. 0.083 times 0.02 plus 0.917 times 0.05. I enter, and that means 0.04751, 0.04751, or 4.751%. It's inaccurate of the total population because I combined them together, right? Okay, a high school basketball team leads at halftime in 60% of their games. All right, so I'm going to stop right there. They're in the lead 60% of the time, which means they're losing. Let's say that they haven't lost yet, right? They're just behind 40% of the time. So that means they don't have as many points. But if 60% of the time they're in the lead, the team wins 80% of the time when they have the halftime lead. So when they have the lead, 80% of the time they win, which means 20% of the time they lose. When they're behind, only 10% of the time when they don't have the lead. So when they're behind, they only win 10% of the time, but 90% of the time they lose if they're not in the lead. So what is the probability that the team wins a particular game? Okay, so I've got this group of probabilities that I need to add to this group of probabilities, and I'm interested in when they win. Okay, so I'm going to take, they win 80% of the time when they have the lead, which is 60% of the time. So I'm going to take 0.8 and I'm going to multiply that by 0.6. And then I've got to add the other probability. They win 10% of the time if they're behind, which is 40% of the time. So they win 0.10% when they're behind, which happens 40% of the time. So I need to multiply these together, 0.8 times 0.6, and then I'm going to add 0.10 times 0.4. So 0.8 times 0.6 plus 10% win when they're behind, which is 40% of the time. So that means they are going to win 52% of their games. So they're going to win 52% of the time, or a probability of 0.52, whichever way you want to use it, percents or probabilities, okay? So on these questions, when there's two different groups to begin with, find the probability in one group and multiply it by how big that group is. And then find the probability in the other group and multiply it by how big that group is. And then add those together and you get the answer, okay? So on homework 5.4, there's only two of these that I want you to try. I want you to try number 17 and I want you to do number 20, and then you're done with 5.4.